Okay? This time, we have a building that has been abandoned. It's worth $450,000 right now, but if you just abandon a building, it's going to start falling apart pretty quickly. So its value is going to decrease by 15% per year. When will the building be worth less than $200,000? Okay, now for this one, Presley, what's our initial amount that we're going to have? Good. And then, Presley, what will we use for our B value there? Good. So we'll do 100 minus 15. What will that give us? 85. We want to change that to a decimal. So what would that be as a decimal? 0.85. So we're going to use 0.85 right here. And then, how long? That we don't know, right? That's what we're trying to find out. So we're just going to put X right there. For this, we're going to write this equation. And so anytime you have a when problem, how long is it going to take for this to happen? You're going to use Desmos to help you do that just by typing in the equation y equals 450,000. Oops, type in y equals 450,000 times 0.85 to the x power. And then we want to know when it hits 200,000, so we do y equals 200,000 here. And I can't see it, so I'm going to here, there, I've got a good picture of when this will happen. I just want to click, look over here where they intersect, and I get 4.99. So 4.99 years. Wonder how long it really would take if I just like left my house right now. Nobody ever went back to it. How long would it take to just fall apart? I'm sure it's different for like how good of a condition each structure is in. But, okay. Questions? Yes.
So I've got the number that y equals 200,000. So when I go to when I go to the graph setting,
So yeah, so that you can see it, if you'll go to the little wrench button and that on that y-axis, change that top number to 450,000, and that'll give you a pretty good picture. Sometimes when you do that, you might still need to zoom in or out a little bit from there, but it gets you sort of in the ballpark if you do that. Okay, other questions? Yes. Let's see what yours looks like real quick. I think maybe you might use it as a capital. That's capital X possibly. Erase it and make it type.
Okay.
Hit the house button. I think you zoomed out before you did this. Oh, that's what you did. Hit the house button. I mean, it'll still give you the answer if you see where they cross, but hit the house button. So yours will look like mine. Hit the wrench down and just change that 45, that top number to 450,000. So what you had zoomed out so far for like the exact huge, but you really don't need to use the exact information. That's what happened. Alright. Although it still would have worked because it'll show you where they cross. You just can't like tell what's happening and stuff. Okay. Alright. Homework, I'm gonna call the answers for it. So let me grab that. That's not it. Okay. All right. So I'm going to call 1 through 8 first. 1, decay, initial value 10. Percent decrease is 25%. 2 is growth. Initial value is 1. Your percent increase is 200%. 3 is decay. Initial value is 5. Percent decrease is 75%. 4 is decay. Initial value 20,000. Your percent decrease is 17.5%. 5, growth. Initial value 100,000. Percent increase is 5.2%. 6 is decay. Initial value is 1. Your percent decrease is 8%. 7 is decay. Initial value 500. Percent decrease 98.7%. And 8 is decay. Initial value 7,000. Your percent decrease is 0.6%. Okay. Repeats or questions on the first one? 8. Yeah, so the percent decrease is 0.6. Number 5, it is 5.2. Other questions from 1 through 8? So whenever you have an equation, so like for that first one, it is y equals 10 times 0.75 to the x power. Growth or decay, you are looking at this number right here. Okay. If this number, your b value, right, we've been calling that the b value, if b is greater than 1, b is greater than 1, you have growth. So if you multiply by a number bigger than 1, it's going to make that number bigger. All right, so you're going to have growth. If you have b between 0 and 1, that is going to be decay. That is going to be whenever you see your decreasing graph. So that particular one is decreasing. And then to tell your percent, for your percent increase or decrease, you're going to do the same thing every time. You're going to take that b value. So like on that one, you got 0.75. Subtract 1. Sometimes you might need your calculator to do that because some of these numbers are a little bit bigger. You'll have your calculator on all of the exponential stuff. In fact, I'm probably just going to give you your calculator on the exponent rule stuff too, because it's really not going to help you that much, and that way I don't have to do 2 parts of the test. So you would subtract 1, which in this case would give you negative 0.25. And then you would move that decimal 2 places. So you get 0.25. I'm sorry, ooh, not 0.25. 25. Okay, so same thing every time. Subtract 1, move that decimal 2 places. All right, questions? Other questions?
So when you get a negative,
Kind of ignore the negative. The negative tells you it's decreasing instead of increasing. Right, so you don't want to say something's decreasing by negative percent, because that would be saying like I'm not going to go to the park this afternoon, right? So you would just set the decreasing takes care of that negative for you. If you want to get really crazy, you could be, if you were increasing by a -%, maybe that's sort of right, but it's really not good to say, right? So, okay, all right, so the rest of the questions, I'm going to call those out. Number 9, you should get $267.76. 10A, there were 432 bears in the park initially. B, according to the equation, the bear population decreases by 8% each year. And after 15 years, there should be 124 bears. That's rounded to the nearest bear. $11 is 4.3 years. $12 is 3,373. 13 is C. 14 is 7,563.15. And 15 is, you're going to get 2.9 half-lives, which is 16,617 years. What? The last one, 16,617 years. Okay, which ones do we need to look at? Okay, about the last one. We did do a little bit with half-life, but we did not write one that used the half-life like this. So, the half-life of carbon-14 is 5,730 years. That is true. It's probably rounded off to make the problems a little bit easier, but it's true. This is what they use for carbon dating. So if you go in your backyard and you find an ancient artifact of native peoples or something like that, then they would use carbon dating to figure out how old that is what they usually do. If they find dinosaur bones, if they find stuff like that, this is the method that they use. So if a sample of material contains 30 grams of carbon-14, how long will it take until only 4 grams remain? So this is a how long problem, right? Does this give us a percent that it's decreasing by? It does not. So whenever you have a half-life problem that does not give you a percent, what you're going to do there for number 15 is you're going to do y equals, we start with 30, and we're going to take half of it over and over and over again. So we're going to have, so if you see a half-life problem and you're writing the equation, you're going to use 0.5 for your x, because that's how long it takes for half of it to be gone. If you think about what would happen here, if we had half-lives and amount. So what's happening, initially we start off with 30. After one half-life, which is 5,730 years, we would only have half of it left. We'd have 15. And then again, half of 15 would give us 7.5. And then half of that would be 3.75. Yeah. And so then you got half of that, and you can keep on going. So we can tell the answer falls somewhere right here, right? Because we want to know when we've got 4, but we're not going to be able to figure it out exactly just from the table. So what we want to do is, when it wants to know when there is 4 grams left. So we are going to type in the equation. And here we're going to just put 4. And I'm going to hit the house button so I can see it. And so I can see that those cross at 2.907. So x is going to equal 2.907. But This X right here stands for half-lives. It's the amount of time that it takes for half of it to go away. So for this substance, each half-life is 5,730 years, right? So this is half-lives, but more than likely, we want to know how many years it's going to take, right? So you would multiply that by 5,730. And so if we do that, we're going to get six. This is going to be a little bit more precise. I need to change my answer. What I have here, I've gotten better at doing these problems since the last use Desmos. So 16,657 years. Okay. Which other ones do you guys have questions on? How did you guys do on number 11? It was a half-life question also, but it was a little bit different. Got it right. So 11 gives you the equation. It's asking for the half-life, so you just have to, you start with 10. You have to see when there's going to be 5 for that. So, so that one is a little, that's more like what we did in class. Okay, anything else? Okay, so I have got a quick check to see how we're doing on this on Canvas. So if you will go to Canvas for me, and go down here to February 15th, there is a quick little quiz right here that says, is it growth or decay? And I'm going to set it right now. I'm going to put a time limit on it because I want us to, I'm going to put a time limit of 5 minutes on this because it is just real quick for us to do this. So it should not have an access code. It's going to say, is it growth or decay? I want you to click on it. It's going to be matching for you to match the ones that are growth or decay by certain percents. And it's going to give you 5 minutes from when you start it. So go ahead and log in and try that. And then once you have done that, we'll go over the answer so that you can retake if you need to get your grade back up. Okay, so let's see what we've got here. And you may want to jot this down because then you can retake it and put the right answers in. If you start it right now, it's going to only give you a 5-minute limit. You might not have time to do it all. So I jot it down as we go over it. The order was probably mixed up for some of you guys, but you should have all had the same questions. This one was not a question bank problem. The order just may have been different. So we've got f of x equals 500 times 1.03. We were doing better with growth as I was looking through. We had everybody except for 3 of you get that one. Remember, it's the same thing every time. You're going to subtract the 1, move the decimal 2 places. So you should get growth by 3% for that one. Okay. G of x. So f was growth by 3 if you want to jot that down so you can make sure you got them right. G of x we did a little worse on. Let's see, we had, it is good that everybody except for the person who did not answer put growth. So this is growth, it's bigger than 1. So whenever you do this, 1.3, you're going to subtract the 1, which is going to give you 0.3. You got to move that decimal place 2 places every time. So you got to fill in with a 0 there. You're going to get 30% for that one. Okay, let's go to H. Here's where we start doing worse. There were 4 of you that said decay by 70% here. It's the same process every time. It's not going to be that number that you see right there. Okay, so you got to do 0.7, subtract your 1. It's going to give you a negative 0.3. Move that decimal 2 places. So you're going to get 30%. And since it's negative, it's going to be decay. We did just a hair better on J. Same thing here. You're going to subtract 1. So we've got 0.97 minus 1 is going to give us 0.03. And you're going to move that 2 places. So this is going to be a decay by 3%. For 1.07, here we had a couple of you, or one person call that decay, but this is growth because that's bigger than 1. Subtract your 1, you get 0.07, which is 7% when you change it to a decimal. So that should be growth by 7%. M, here you should get growth by 70%. Subtract the 1, you get 0.7. Move that decimal 2 places, you're going to get 70. Oh, we did horrible for N. So let me write this one up here. So you've got 0.3. You're going to subtract 1, which is going to give you 0.7. You're going to move that decimal place 2 places, and you're going to get 70%. Since that's negative, it's going to be decay. Lots of you put decay by 30. Remember, it's not going to be the number that's there, especially for decay. The only time it will be the number that is there is if it's 50%, right? Half, because if you do 100 minus 50%, you still get 50%. But any other time, it should not be the number that you see here. For P, a little bit better on this one. This is decay by 7. Again, you're taking that 0.93. You're going to subtract 1. It's going to give you negative 0.07. Move that decimal 2 places, 7%. Oh my. These are tricky. But we did really, really, really bad on Q here. We only had 3 people get it right. It must be the 3 that made 100 because there were only 3 of you that made 100. So, when you have a whole number, it seems like it should be, like a lot of you put 100%. Some of you just put the 7 there. Some of you have a 3. I think that was probably a guess. So, subtract the 1. That gives you 6. Move the decimal 2 places to get 600. When we're talking about growth, if you multiply by 7, that's 600% growth. If you multiply by 9, it'd be 800% growth. Multiply by 2, it's 100% growth. So that's. And I'm going to imagine we did not do so well on this last one either because we have a whole number here, but let's check it out. We did a little better. I had 57% get that one right. So, same thing. 2 minus 1 is 1. Move that decimal 2 places to get 100%. Okay, questions? All right, so this tells me that some of you need some work on that. So if you're still having trouble with that, make sure that you ask some questions about it when we go over the review work. Make sure you have do some extra work with that. Anybody have any questions right now? P. For P, you're going to take that 0.93, subtract it from 1, or subtract 1, so you get 0.07. Move that 2 places, you should get decay by 7%. So if you did not make a 100, go back in and retake it right now and make a 100. Because it's going in as whatever your grade is. So if you made a 0.6, it'll be a 0.6 out of 3. So you have no reason not to go back and redo that now. I have about decided that I don't need to teach you how to use the calculator on this because Desmos is better and you get to use it on your exam. So we are not going to do these calculator directions that you see here. I left them on here just because I didn't want to redo these notes if I decided to go back and teach it again later. But we want to look at these Desmos directions here. So I'm going to put this over here so I can still see this on this page. And I'm going to split screen this with Desmos. You guys please pull up Desmos on your computer because I want everybody following along. And we did this just a little bit when we did the M&M lab, which we still haven't finished up. And I'm thinking we'll do that tomorrow because we're running short on time here today. So, Desmos is really straightforward with this. I feel like it's 100 times easier than using the calculator. So, let's make this a little smaller so we can see all the data. Okay, so the first thing you're going to do is put the plus sign, add a table. So everybody do that on yours. And then you're going to enter your data. So enter this data, please, into Desmos. Alright, so everybody got their data in. I can't see mine. It's not there at all. So I'm going to hit the wrench. My biggest number is 3,100. So for right now, I'm just going to go change my Y to 3,100. And then you can kind of zoom in and out a little bit from there. So this is what I've got. Y'all missed out. Getting stuck with me instead of Coach Wood. It's excitement every day. Alright, so here in the corner you're going to hit the wrench, and then down here where it says Y-axis, you want to change that top number right there. I changed it to 3,100 because that was the highest number I saw on my table. Or you could go a little bit bigger. And then I just zoomed out a little bit more so I could see the graph a little better. Okay, has everybody got a graph? Okay, so we want to So we did linear regressions. We also are doing exponential regressions. We want to compare these a little bit. Mostly I'm going to give you stuff where it's exponential regressions because that's our focus right now. But I will also give you a few that are linear just so we can compare how well it works. So to do a linear regression, you're going to type in the equation of a line. And a line was y equals mx plus b, right? So you do have to put a 1 after your y. You got to do squiggle mx1 plus b. And then you should see a line show up there. There's Jada. So glad she's here. And Jada, we did it was just like a little quiz online. It's not like a quiz grade. It's a homework grade. So for homework tonight on Canvas, do the one that says, is it growth or decay? And if you're having trouble with it, we went over it in class, and it'll be on the video. If you'll click on the note video there too. All right. And so that's our line. Everybody got their line? Okay. And then we're going to do, for our exponential, we're going to do y1 squiggle. And for our exponentials, we do a times b to the x1. All right, so make sure you've got both of these showing up. I'm going to come around and see that everybody's got it. You probably zoomed out first. Oh, you're the next one. All right, you probably zoomed out first. So if you will hit the house button, and then hit the wrench, and then go over here and change just that number right there to 3,100. And then 310. That highest number over your page. Okay. And then you might need to zoom out a little bit more, but that should get you, that looks better so you can see it better. Presley, I think you probably zoomed out first, so then like your x-axis is super big and you can't see it. So if you want the house button, and then hit the wrench, and then go down there and change that to 3,100, I think you'll get a better picture. Yes. I think you may have put in a number a little bit too big. Instead of 3,100. Hit the wrench button. Change that Y right there to 3,100. And you're also your Y is related. So a lot of you are having trouble getting your picture right. So what's happening, I think, to a lot of you is you get here, you can't see anything, so you start zooming out like this. But then when you zoom out, all your points just look like they're on a vertical line, right? So if you just zoom out, especially in this case, because our X's are really small, but our Y's are big, so it's only our Y that we need to make bigger, right? When you zoom out, it makes the X and the Y bigger. So if your picture doesn't look good right now, hit the house button for me. That takes you back to the standard view. All right, so you'll want to hit the house first, then hit the wrench, and then you want to change this Y, just the upper number on your Y, to the biggest number you see on your table, which is 3,100. And then that'll get you close, and you can zoom out a little bit more to where you can see the picture better. Now, which one appears to fit better here? The linear or the exponential? Exponential is what I would say. And we can know for sure which one fits best because we can look at our r-squared values. So the r-squared right here is only 0.865, but right here r-squared is 0.9966. So the one with the higher r-squared value fits best. Sometimes they're a little closer and it's harder to tell. This one's pretty clear that the exponential is better. Okay, now let's talk about how to write these down. Let's see if it's on. All right, so let's write it down over here on this. So when you're writing your equation, okay, when we're doing the linear equation here, okay, linear is this y1 equals mx1 plus b. We're going to write y equals our m value, 212.342, times x plus b, which in this case, since b is negative, actually I'm going to make it a minus. Minus 242.777. So you're just taking those values that you get for m and b, and you're plugging them into m and b in the formula. So if you are asked for a linear regression, a line of best fit, a linear model, any of those things, you're writing the equation is what it's asking for there. Exponential regression is usually called an exponential regression or an exponential model. It's not called a line of best fit because it's not a line, it's curved. So you're going to write y equals, and then a is 168.068 times b, which is 1.25082. Keep the whole number because it's going to be important to do that on these exponentials. Don't round those off, and it'll be to the x power. Okay, any questions on how to write those down? All right, so according to the exponential regression, right here, I'm going to put my exponential regression, so I'm looking at it. Yep. I put mine over here, but if you put it there, it's fine. So we're on the third slide now. All right, so whenever it says according to the exponential regression, it means the equation there. So this is talking about the equation that we have here. Put that down a little bit so I see it. So we got y equals 168.068 times 1.25082. We're answering this question based on the equation, not on the table that we see. Okay? So according to the exponential regression, Marley, what would the initial wolf population be? 168. I'm going to go ahead and put 068. Now, it does not make sense to have 0.068 of a wolf, but that's what our regression tells us, right? Because the regression is just looking at numbers. It doesn't know that these are wolves and that it needs to round. So we're just going to use the number that it gives us there. Now, sometimes I might ask you to round to something there, but we'll usually have the decimal. At what rate is the wolf population growing? Okay. Now, our rate is going to come from our B value, but it is not our B value, right? So, from our B value, we got 1.25082. We're going to subtract 1. Right? Just like we were doing on that little quiz that we just took. And that gives us 0.25082. And then I've got to move that decimal 2 places to the right. So I'm going to get 25.082%. Okay. Now I'm going to get rid of my line actually here. And my next question says, how many wolves will there be after 25 years? So you got two options for how you're going to deal with this. You can just plug 25 into your equation, right? So you can do 168.068 times 1.25082. Make sure you don't round those numbers to the 25. Right, and so if we do that, it's going to give us 45,220. I'm going to round that to 223. Okay, your other option here, years. Is that X or Y in our equation? It is our X in our equation, right? So here's another option that you can use. You can type in X equals 25. Now, I can't see it because this stops over here at 20, so I'm going to zoom out just a little bit more. And I would actually have to zoom out a lot more. Ugh. Probably have to hit the wrench. Change this to 45,000. Maybe make it a little bigger than that. 60,000. And so up here I can see where they cross, and I can get for 45,219.825, which is the same thing I got. I think it's easier just to type it in on this one because you got to zoom in and out so much for that. Sometimes this can be quicker though. Zoom in to where I was at. Okay. Now, the second one we don't have a choice here, though, because we don't know how to solve this by hand if we are going to see when the population will exceed 6,000. So, Katie, what should I do to figure out when the population is going to exceed 6,000? Perfect. So I've got my equation in here. I'm going to type y equals 6,000 in this line. I'm going to zoom out a little so I can find it. And there it is. I've got 15.975. So we would say 15.975 years. The questions you're going to get for this are the same as they've been with the ones that just gave you an equation or you had to write an equation for. But in these cases, you're using your data to come up with a line instead of writing it yourself or being given it. Okay, questions? Okay, these are last year's numbers. Let me just look and see where we're sitting at today. See if we're close. I have not tracked this over the last time period, so I can't just go to it, but we can click and see where we're at today. So today we're at 3,000 people hospitalized with COVID, 3,094 in the state of North Carolina, in case you were curious, because I always like to look at the numbers. So, and we were obviously doing this a little later than we were. We went to 25, so we're a little higher than we were this time last year. But hopefully we're on a downward trend, so hopefully we're going to see this continue to go down as we were seeing this here. So last year, I just had the question, how many people are hospitalized? What trend are we seeing? So this was last year's data for the state of North Carolina. So we're going to type it in. So get rid of everything else that you have first, and then hit the plus sign and do the table. If you don't get rid of everything else first, you'll see your table's called X2 and Y2, which means you need to use an X2 and Y2 instead of X1 and Y1. So we're not going to type in 2, 1, 2, 4, 2, 9, 2, 12. We're just going to type in 1, 2, 3, 4, 1, 4, 9, 12, right? 1, 4, 9, 12, 13, 16, 19, 25. So type your data in. And I actually have a pretty good graph right here, but I'm going to make this I'm going to make my y's a little bit smaller. So the highest number I had is 2,741. I'm going to just go with 3,000. That's close. And I'm going to put 0 here on the y-axis so that I can get a little bit better picture. Now, do you guys think that looks like it's linear or exponential? I put the 0 here for the lower number, so I put a 0 right there, and then, because we know the number of people in the hospital is not going to go below 0, because that would be, you can't have negative people, right? Even if the hospital's empty, it's 0, and then I put 3,000 for that top number, or I could have used the highest number, and then I zoomed out a little bit more, because you do want to be able to see that x-axis. Our numbers before weren't that bad. We could have done it from where we were at, but this lets us see our dots a little bit better. What do you guys think, linear or exponential? Okay, exponential is going to be curved. Linear will be straight. Is this one as easy to tell as the last problem? It's not, right? It's pretty straight. It's definitely not really curved, but it's not perfectly straight. So this is where it's really helpful to have the calculator to tell you what fits best. And then also sometimes you just need your common sense to see what patterns are going to do. So let's do linear first. So y1 squiggle mx1 plus b. All right, so we just type in y1 squiggle mx1 plus b. The question over here asks us for the linear model for the data. So I'm getting y equals negative 53.3521. I hope you guys are getting the same thing and I didn't type something in wrong. Same thing? Good. 2,759.4. Alright, now over here, it didn't ask for this, but over here to the side, I'm going to write down my r squared, which is 0.9907. So that's a pretty good R value. It's pretty close to 1, right? So we could make predictions using this line, and it would probably be pretty good. We also need to do our exponential. So we got y1 squiggle a times b to the x1 power. And so for this one, we're going to have y equals 2,831.37 times 0.974638 to the x power. And this time, the r squared, I don't know why it's capital, but it is, but we can still compare these, is 0.9885. This is the exponential model. So, so for the first one, that was linear. So that was y equals mx plus b. It gave us a line. For exponential, you're doing a times b to the x power. So that's what your graph, you'll just plug that a and that b into that formula. Now, the green line looks pretty good too, all right? Which one, statistically speaking, should fit better? Which has the better r squared value? The linear, right? So statistically, purely based on statistics, the linear model fits better. Okay, so we want to, I'm actually going to use both lines because we're going to see something crazy happen here, I think. All right, so we want to use our best model to predict the number of people hospitalized due to COVID-19 at the end of March. So in this case, one was like February 1, right? So we got 28 days in February this year, right? No, leap year, be 24, right? So 28 days in February plus 31 in March, right? So if we do 28 plus 31, we're going to get 51 days, right? No. 59 days. 59 days. So, I want to know what's going to happen if I plug in 59, right? So, if I plug, my linear model was best. So, to do that, I do negative 53.3521 times 59 plus 2759.4. And look what I get. So, linear is going to give me something that we just said can't happen, negative 388.3739. We can't have negative people in the hospital, right? The very lowest number of people we can have in the hospital is 0. So that would be a unreasonable prediction. So our linear, although it fit best statistically, we know that there's limits on how much we can use this, right? So whenever we're doing linear regression, there's going to be limits on what you can look at for trends. So right now well, actually this was last year, but we're still seeing the same downward trend right now. So we're seeing downward trends in COVID hospitalizations, but downward trends are not going to continue at the same rate forever, right? Eventually, maybe it might get to 0. More than likely, it's probably never going to get all the way to 0. You're probably always going to have, hopefully not as many, but a few people in the hospital with COVID. Hopefully over the summer, they're saying it'll be more like the flu, so over the summer not as bad, and the winter gets a little higher again. But this doesn't look like a good prediction. We've gone too far outside of our range, right? If we predicted if we predicted when it would get to 1,000 right here at 32 days, that might be a better prediction. But we've gone too far here. Just so we can see, let's see what we'll get for exponential. And for exponential, we would plug into our exponential equation, so that'd be 2831.37 times 0.974638 to the 59th power. And so the exponential prediction is 621.947. Does that seem reasonable? That looks a lot better, right, actually. All right, so knowing what we know about disease, if we were researching this, even though the linear model fits better, we would want to go with the exponential model because we know that's not just going to plummet and go to negatives. It's going to sort of slow down. And actually, eventually it's probably going to go back up, unfortunately. Hopefully not like it has been lately. But we would see that happening. So your assignment that you're going to have is a worksheet. And on this worksheet, you've got you know how to type these into Desmos, right? So on the back, you just have tables, all right? And on those tables, you are going to find the regressions for you. There's no questions about them. You're just typing them in and writing down your regressions, okay? So for each one of these on the back, you need to find the linear regression, find the exponential regression, write down your R-squared values and tell which one fits best. Okay, so just two that are word problems. The back are just typing in. They should go fairly quickly. Okay, any questions? All right.